Hello from Decision Lab. Today we're going to show you how you can orchestrate your Microsoft Azure infrastructure and manage your Azure security policies as code, all with Salt Cloud. Let's get started. We'll start off with our Azure Portal UI looking at the resource groups. As you can see here, we have no resource groups here at the moment. We're going to change that real quick. Let's switch over to the terminal. Here we have in our orchestration file the set of states that are going to create all of our resources. These are all states that Salt is going to use to do our work for us. Here we have our execute cloud config creation state. This is going to create all the configuration files necessary for Salt Cloud to interact with Azure and to create our resource group, our virtual machines, all the other details. Next is going to be the scaffolding creation. This is worth stepping into for just a few more details. This is going to do the real heavy lifting, the actual creation of the resource group, the creation of our security groups, and all of our virtual networks and everything else that we take for granted when we deploy into the cloud. Here we're creating our Bastion security group. Everything that we deploy is deployed in a secure manner. For this demo, we'll be going through a Bastion host when we interact and deploy our solution into Azure. Our second security group is going to be used for the web UI for our Splunk demonstration. Down here you can see the virtual network stanza being created and a single subnet that all the machines are going to live on, along with all the details, the network CIDR that we want for it to have. Moving on, once all of those configurations have been created, the next step is to execute a cloud map run. In Salt, cloud map files describe the footprint of a deployment. So this is going to create the virtual machines for us. Having created all of the network artifacts, virtual networks, and subnets, this is what's going to create our VMs. Like we mentioned earlier, we use a Bastion host, which means we're going to be using Salt SSH to deploy our Splunk deployment for this demo. As such, we're going to need to configure our local Salt SSH client to reach through that Bastion host to get to all of the other machines on their private subnet, because all of those machines cannot be reached on the open internet. So we jump through the Bastion host. The last part is going to be the pillar creation for a successful Splunk deployment. You can think of pillar as a sort of dynamic configuration set that can be used on a per deployment basis. So let's go ahead and go back to the command line and fire off our orchestration command. Everything that we just finished walking through is going to get created. This can take a little bit of time. Azure is a very complex ecosystem, so we're going to go ahead and hit the fast forward button and move this along a little bit. So we're at the end of our deployment, and we can see that the total runtime is just a little bit shy of 5 minutes total to create all of our virtual machines, all of our network artifacts and everything. We're going to do a quick test.ping against all of our VMs to make sure that they're actually alive. And with that success, we're going to switch over and we're going to see what these look like over in the Portal UI. So if we come over here and look back at our resource groups, we can come up and hit the refresh button. And we can see that our resource group has been created. Let's go ahead and have a look at that resource group. We're going to go to the overview panel and we see all of the resources that we asked Salt Cloud to create for us. Here's all of our virtual disks that are attached to our virtual machines. Each one of them has their own network interface to go along with it, along with the two network security groups that we went over before. And following that is going to be our public IP addresses, one for the Bastion, one for the search head. And we have our actual virtual machines down here. We've got our Bastion host we're going to go through, 2 indexers, 1 management server, and a search head for our Splunk deployment, all of them living on our virtual network. And before we leave, I want to switch over and show over in the policies panel for this resource group that we have no policies at the moment. We'll get more on that later. For right now, let's come back over to what will be our Splunk deployment. I had mentioned previously that the pillar system in Salt is a sort of a dynamic configuration for your deployments. We're going to look at our pillar file for Splunk right now. We can see up here, we've got our Splunk top level key. We're talking about the Azure demo deployment name. We're going to be using Salt SSH to go through here and deploy it, so we set that. We've got our other configuration details, and then begins our list of minions, which 1 minion per virtual machine. Our first one is going to be our search head, and we're going to pass it a few configs that are a little important for this demonstration, specifically turning on SSL and configuring port 8000, followed by our 2 indexers, and finally our management node. Leaving that, we'll go ahead and set up the orchestration command to begin the deploy of Splunk onto the virtual machines that we just created. And just like the other things, this can take a little bit, so we're going to go ahead and fast forward this. So we can see this Splunk deployment took about 8 minutes for the run. So now that that's complete, we're going to source in a little credential file here so we can make these commands quick and painless. The next thing I want to do is grab the public IP address, so that way we know where to go to log into our Splunk UI. So we have a SALT module called Azure Network with a function public IP address get. We've plugged in a few more config details, such as what resource group, what resource we're going to be using, and then we give it some usual boilerplate credential details. Normally when you're using states, these details come supplied via pillar, but out here on the command line, we'll need to supply them ourselves. So we're going to go ahead and fire that. And we get back a lot of details, but what we're interested here is the IP address field. So we're going to take this IP address, and just to be sure that we've got it right, we're going to go ahead and switch over to the portal UI real quick. We're going to switch back over to our resource view, scroll down to the public IP addresses that we created. We're going to look at the one that's assigned to our search head, which is what we just asked for with the module, and confirm that the IPs do match up. With that knowledge, we'll take that IP, we'll open a new tab, plug it into our browser, and go ahead and log into the Splunk UI. So we have a successful orchestrated Splunk deployment. Having gone through the orchestration, we're going to move on now to policy management. We'll be honest, policy management isn't the most exciting material, but we do have to meet regulations and rules and laws. So the goal here is to make policy management as easy as possible and have the machine do as much of the work as we can. So that way we can spend more of our time doing the more interesting, valuable work. So going back to our terminal, we're going to open up a state file. I'll walk you through the details of what we're about to run. And it's just going to be 2 states. One is going to be our state to create our policy definition. We come down here, we can give it a human-friendly name that we can recognize it by. We add in a few more details to make it easier for other people to use. And down, we finally get to the policy rule. We've written in YAML what we want our policy to look like. We don't have to use YAML. We can use the normal JSON body that we're accustomed to seeing. We can manage it on disk. We can manage it from a remote URL, such as a GitHub or a Bitbucket server. Whatever's the easiest way for you to manage, we can do that with SALT. So in Azure, a policy definition is exactly that, a simple definition of a policy. To do anything, we need to create an assignment, and that's going to be our second state. So here, we're going to create our policy assignment. We give it our human-friendly name. We define the scope. In this case, the scope is going to be the specific resource group, but you can make it subscription-wide or whatever scope level that you need it to be. The next parameter is going to be the name of the definition that we are going to assign it to. And we have the usual other details that are useful for other teammates. So let's go ahead and run that command. We'll give it a second to come back. And success! We've created our policy definition and we've assigned it to our resource group. And what we can do to prove that is let's get a listing of the definition as it appears in Azure. And we can see that it matches up with what we specified. We have the name that we needed to have, and we have our policy rule details. So the last thing that we'll do is confirm that the assignment is in effect. So we're going to ask Azure for a listing of all active assignments. And right now we only have our single assignment, our prevent VM creation assignment. We can see that the scope is what we asked, is our resource group. So if we come back to the UI, we look at our resource group, we get a listing of the policy panel, and switch over to our active assignments, we can see our assignment appears in the UI as well. We've got the assignment ID. And if we switch over to the policy rule, we'll see the familiar JSON format. We've got our effect of deny, we've got our conditionals, if we need to write to the Azure Compute, along with the locations that we care about. So now that we've confirmed our assignments are enforcing, we're going to attempt creation of a virtual machine. We have an extra Salt Cloud map file here just for this purpose. We have a single VM called test VM we're going to create. It's going to go into our Azure Demo resource group. We'll put together the Salt Cloud command to use that map file and make an attempt at deploying our virtual machine. So what's happening right now is Salt Cloud is querying Azure to see if there are any machines that go by the name test VM. Once it confirms that there's no machines by that name, it'll continue with the attempt at creating the machine. And we're immediately denied by this request disallowed by policy error. So we can see that our policy is in effect. Salt Cloud failed to create the machine. In the response, we're giving a little bit of debug information, disallowed by policy, and some policy identifiers so we know exactly which policy it was that stopped us from creating this. So now that we've shown that the policy in effect is enforcing successfully, we're going to delete the policy, get it out of the way. Let's go ahead and confirm there's no more assignments in place. Should be an empty list. And now that the empty list comes back, so there's no more policy assignments in effect. So what we're going to do is make a second attempt at creating that VM. And we'll go ahead and fast forward this a little bit since instance creation can always take a little bit of time. And here we see the instance created successfully. So we're going to go ahead and clean up after ourselves so we can move on to our next policy demo. Policy enforcement is useful, and disallowing certain actions is always good, but sometimes we want to take a slightly gentler approach, and instead of outright disallowing an action, we can instead encourage people to do the right thing. So let's use a built-in Microsoft Azure policy to automatically tag instances upon creation. We'll start by coming back over to our terminal, and we'll walk through the salt state file that we have that's going to create that policy assignment for us. We're using a built-in Microsoft policy, so we don't have to write the definition state. All we need to write is going to be the policy assignment state. So we'll do the usual, give it a human-friendly name so we can find it later. We define the scope that it goes in. Again, it's going to be the resource group. The definition name is going to be the difference. Since we're using a built-in policy, we use the UID that Microsoft assigns to it. You can find this in any listing, in a call from the command line, or from browsing the UI. We still give it the usual display name and description. And in this one, we're going to supply parameters. So since we're going to be creating a tag, we need to specify the tag name, and we're going to specify the value that that tag is going to have. So that when the instance is created, the policies will be sure that those tags are automatically applied to the instance. We'll go ahead and create that assignment. And let's go ahead and verify the assignment is in effect. Okay, so we should be good to go. We can see the tag name and the tag value is as we've asked it for. So let's go ahead and create that test machine again. We'll fast forward this since this takes a little bit of time. And we can see that the policies have ensured that the tags were created successfully. We have our tags key in the output with the tag name and tag value that we wanted. So the last thing that we'll need to do here is to clean up after ourselves. We've organized everything inside a single resource group in Azure, so it's going to make it pretty easy to clean everything up. In here we have a single state file with a single state using the resource group absent function out of our Azure on Resource module. We're going to specify the name of the resource group we want. And we're going to go ahead and fire that command. I would also please caution you to please be careful when using this, as you can delete an enormous number of resources when doing this. We're going to fast forward this because it can take a good amount of time depending on how many resources you have. Now that we've cleaned up, let's switch over to the portal UI in our browser. Let's confirm that we've successfully cleaned up. Coming back over, we come over to our resource groups panel. Let's go ahead and hit the refresh button. And the Azure Demo Resource Group is gone. We've successfully cleaned up after ourselves. Thank you for taking the time to watch this demonstration. If you have any questions or you want to get in touch with us to see what else we can do for you, please reach out to us on our website. Thanks again, and have a great day.